deeper in on more of a technical side with our excellent panel here. But we might be kind of diving into some of the other themes that were brought up earlier here today. But when it comes to artificial intelligence and frankly exciting technologies that we're seeing more and more of it available and accessible to people, that AI didn't come out when you saw the mid-Germany images popping up in your social media. It's been around for a while, and what we're going to be touching on a little more here today in this panel is some of the exciting ways that artificial intelligence is being used in image analysis and visualizations, and bringing some of that kind of background technology to the forefront in a visual way that we can look at and really optimize different ways that we are working. So my name is Corinne Guznoski. I'm Senior Manager of Business Development at New Media Manitoba here, but I'm more so located across the street. And I know each of us are already up here, so I'm going to actually call on each of you to give an introduction of yourselves. So a couple minutes here. Jason, I'll start with you.
Thank you so much, and thank you for coming today. I'm Jason Shields. I'm an assistant professor at the Department of Interior Design. A lot of the work that I do relates to the use of advanced technologies such as LiDAR, 3D scanning, virtual reality, and a lot of the research that I've been doing involves the use of it and the visualization of it. So a good example that we'll be seeing later today is I recently 3D scanned the Bruce Head wall. So if you guys walked in from that direction, there was a large kind of art piece wall, the largest in situ art piece in Canada. And so I've been working on 3D scanning that, transposing it into a virtual reality environment, and we'll talk about that a bit further. And I've been doing some drone work as well up in Churchill, Manitoba, and we've been working with archaeologists and internal medicine to work towards mapping and looking at the previous Indigenous shelters and spaces of the past. So yeah, that's what I've been up to. And Chelsea?
Sounds so boring, Jason. Pleasure to meet all of you. I'm Chelsea Trabaniak. I'm actually stateside in Ohio and came out to you for a couple different reasons. One, we do a lot of work with drones as well. We refer to it primarily as remote sensing, and got in touch with Carol years ago at the Manitoba Construction Sector Council. So we teamed up and brought Sky Skills. If anybody in the room has taken it, we actually created the program around how to use drones in construction and then basically get your basic certification. We also built on that and then have an advanced Sky Skills, and then starting Wednesday, we have a next level collaboration between MCSC and New Media Manitoba that has LiDAR and extended reality. So taking those point cloud models, which obviously are generated by using LiDAR, and then merging it into extended reality. That course kicks off Wednesday. So happen to be out here, and I'm thrilled to be part of the Hyper panel. I do a ton of work with AI, especially in the transportation world alongside drones, but then also have a separate arm of the company that focuses on AI use cases relative to fraud. So that main focus is within the financial sector, and I'll be elaborating on that today.
Good day. My name's Chris Henry. I'm from the Department of Computer Science at the University of Manitoba. I did my PhD in a computational intelligence laboratory, and about 11 years ago, I jumped into machine learning, both for theoretical contributions and applications, because it was I was very close to the area I was working in, and as you see today, all of the exciting developments are made possible by some things that happened about 13 years ago. The area that I work in for application is primarily agriculture or digital agriculture, as well as remote sensing, and I'm excited to talk about some of those developments today.
Hello, everybody. I'm Sean Usher. I'm with Republic Architecture, so I'm here representing the design and construction industries, at least as it relates to buildings. I've spent the last 10 years in this industry trying to make a difference in ushering in new technologies. One of the biggest ones is building information modeling, a totally different approach to how we design built assets, looking at virtual models that are rich with data. And in addition to that, so I teach that at the University of Manitoba's extended ed program of the same name as well, Building Information Modeling Management. I do a lot of work with LiDAR. I have a background in visualization. I got connected with New Media Manitoba when I started using Unreal Engine for visualizing our architectural models and creating immersive experiences of our to-be-built buildings for our clients. So In addition to that, I get involved with a lot of capture on the LiDAR side with Chelsea and the MCSC. I was helping them with their program, and that's just starting tomorrow, I think, for testing. So yeah, I'm excited to be here. I tend to talk a lot, so I'll just stop.
Excellent. Well, lovely to have, honestly, such interesting and broad experience here on the panel. And already I'm hearing some interesting terms. So recognizing that we've got a mix of folks in the audience here. Again, thanks, Margot, for getting everyone to do the hands so we have an idea of who's in the room here. Couple of things that wanted to touch on was maybe some of the terms that comes up when we're talking about artificial intelligence in these areas. I know, say for myself, working in interactive digital media, I've had people come up and say, oh, okay, are you looking for journalists? And it's like, oh, okay, let's take a step back and define it a little bit more. I know for us at New Media Manitoba, we're often working with folks in video game development and interactive web and app development, but I heard here as well extended reality. So when we're looking at that, it's including anything from augmented reality, virtual reality, and mixed reality, all in that umbrella. And say Unreal Engine being one of the tools in that allows us to create experiences and within a kind of video game development environment so that we can have some of these kind of 3D experiences, 3D visualizations. So wanted to open up here of maybe some definitions. I heard point cloud. So maybe, Chris, if we can jump over to you to share more about what that means.
Sure, yeah. Point cloud is a different type of data that machine learning algorithms will work with, or artificial intelligence. You see a lot of you are using ChatGPT and Gemini. Those are text-based algorithms. They're called a type of generative algorithm. We can talk what that is in a moment. A lot of what we're used today was developed from image analysis. So images are, a primary data type that is used with machine learning algorithms. For point clouds, we move into 3 dimensions. So you have some object, a 3-dimensional object in our reality, our world, and you can either use a scanner and scan that object get a representation of it in a computing system where each point in the system represents that 3D object in a 3-dimensional space. And you can do other different types of imaging. There's hyperspectral, multispectral data where we tend to use images that are red, green, and blue, and those are 3 bands, but you don't have to stop at 3. You can have 6, you can have 8, you can have 255, and each one of those corresponds to a different wavelength.
I'm going to add additional clarity because any other parents in the room? Yeah. Yes, I have 3 boys, and needless to say, every day of my life I'm trying to explain a little bit easier on how life actually works. So I also come from a military background, so I had a variety of soldiers that too I had to explain, this is your weapon, this is why it matters, etc. So a huge nerd in me comes out in this moment to say, how does all this work? And I think if you backpedal it to say, let me backpedal it into a way that I can understand it, when I explain to my kids, I have them walk it through. What is step 1? And why do I do step 1 and walk me through that way? So when I break down AI from that angle, it's all about data. So if we begin with data and data collection as step 1 in all of this, where am I getting that data from and how am I getting it into an organized environment? That's where you hear the word structured and unstructured data. So we'll talk a lot about that, I'm sure, on our panel here. But once we have that data in one spot, what do we do with it? Well, we have to clean it, and then we have to normalize it in a way that we all understand it. So this is where we start to extract features. And when I extract features, that's where I start to add those algorithms in. So the 0 is the 1, the programming language starts to come in at that level. So once I have the feature extractions, this is where I can start to build models around it because I'm trying to minimize error off of the data that exists so that then the model can infer different outcomes. And eventually it learns off of itself. And this is where we start to say machine learning, because that's where machine learning is more internal, or deep learning, where it's able to pull those external sources in. And then finally, that continuous feedback loop is what we're all seeking, where that human intervention comes into play. Now that the machine is learning from itself, it's pulling in from other, we're trying to minimize error, that continuous feedback loop is working. So that's AI in a nutshell. And then when we go beyond that, we start to say generative AI, we start to say agentic AI, and we go conversational AI. This is where we're starting to say generative, building off of itself. We start to say agentic in that I have a goal, but I want you to create the steps to get there. And then conversational blends the two. So when we say all these terms, this is where I find breaking it down in parent style to go, where do I feed into that? We can start to combat some of the different things that are out there in terms of where does that label or that terminology blend into the sphere, and how does something like a point cloud become a part of the conversation?
Yeah, absolutely. Great additions there. I think, especially on that foundational piece, large language models, if somebody wants to touch on that.
Sure, thank you. Yeah, that was great, defining the definitions. And so if we wanted to take a step back and talk about artificial intelligence, we're looking at systems that want to mimic human behavior. You mentioned machine learning, and so that's a subset of artificial intelligence where instead of explicitly telling the algorithm what steps to take, the algorithm infers what steps to take from extracting patterns from the data. And so that's primarily what most of the artificial intelligence that you hear about in the media or that we're using nowadays, that's the primary area. And then within machine learning, there's supervised learning, unsupervised learning, and reinforcement learning. So supervised learning is where someone has taken the trouble to create a data set where we have lots of examples, and those examples have labels. And then we can develop these machine learning algorithms by giving a label. So for instance, this is a picture of a cat. And we give the cat, we present the cat to the algorithm, and we see if the algorithm can determine if it's a cat. If it can't, we slowly make adjustments, and we try a different one. We give it a picture of a dog. And if it can say dog, we know it's a dog because it's been labeled. Well, that's great if someone can come and label, 1.5 million images of cats and dogs and airplanes. But in real life, that takes a lot of time and effort, and it's the most costly part of machine learning development. So you have this other area called unsupervised learning, where you get a bunch of data and you just try to infer patterns and extract information from this data. And that's where we get to this idea of large language model. A large language model falls into a category called generative methods. So a generative method is something that creates some sort of output. We're all familiar with ChatGPT and Gemini because they generate text for us. So that's what we say when a large language model, and we call it large because these algorithms have billions and billions of parameters. And then just one other area that is popular in machine learning is reinforcement learning. And often, like the Geminis or the really useful tools or cool applications like AlphaGo, they're a combination of supervised learning, unsupervised learning, and reinforcement learning.
Absolutely. I know some other terms that we were talking about as well, LiDAR being one of them. Sean, I know I heard you mention that. So yeah, if you can explain more to us about that technology.
Sure, yeah. I mean, LiDAR is a technology, it's a laser technology that we use to measure the world. So Chelsea and I have done a lot of work with LiDAR. So with this, we're using LiDAR sensors to measure and capture the world so that we can bring it into a digital format, which we can, for my cases, use to generate building information models or infrastructure information models that we can use for various design purposes, or simply just to have as digital resources. You start to think about what's capable when you're digitizing the physical world and turning it into data-rich models. You're able to start looking at what is actually in that pipe by simply clicking at it, or maybe you have an AR goggles on that can just show you what's going on in the building. These are the types of things we're working towards there. I don't know if you want to build upon that.
Definitions lady coming back out. So LiDAR is light detection and ranging. And so when you attach it as a sensor handheld, or a lot of the work that we're doing is with drones, it's actually taking that light, reflecting it off of an object and bouncing it back. So it is very much a volumetric tool because it is measuring that speed to determine different volumes. The quality and the accuracy you can get off of LiDAR is incredible, just because it is determining what that speed is. And then obviously from construction use cases, if I want to be incredibly precise on my next measurement or volumetric estimate from materials, too easy to grab that level of detail off of the volumes that are listed. The struggle is obviously in the name, and that's why I bring up the name, light detection and ranging, in that it's highly reflective. So one of the difficulties and one of the things we're trying to combat is off of reflective materials like snow. How do you specifically continue to allow LiDAR to be effective? And especially when it comes to construction use cases in the off season. If I'm trying to scan those missions in the wintertime with lots of snow, it becomes a little bit more difficult, to say the least.
I'll add to that as well too. When we often talk about LiDAR, it often gets referred to in a drone setting. And so a lot of the work that I've been conducting as well is using a LiDAR scanner, which is on a tripod pretty much. So I often kind of describe it like an owl. Its head just goes 360 degrees and it sits in one direction. And the other interesting factor I like to often work with my students when I try to introduce them to LiDAR is having them just use their phone. I think almost every iPhone now has LiDAR built into it. It's kind of a quasi-LiDAR. It's not as strong as the $60,000 scanner you might attach to the drone, but it will definitely give you an understanding as to how that functions. And so a couple suggestions I give to my students is try out something like Polycam. Just scan like just the salt and pepper shakers at your house. And usually once I have them do that once, they start to understand the power of that scan and how it can actually be transposed into so many different ways. So I think that when we talk about this idea of LiDAR, there is this kind of more consumer level LiDAR that anyone can take out of their pocket and be able to work with, but there's also this just kind of vast network of different tools and hardwares and softwares that work with LiDAR. So it's a really large encompassing idea.
So Jason, while you have the mic there, I know you were going to be sharing more about other projects you've been working on, but I know photogrammetry, I don't think we've mentioned it yet today, but if you want to share more about that, or say like digital twins.
So photogrammetry, and we've done a bit of that at the university, and right now that's typically done, or at least how we did it in the past, is we would go out there with a digital SLR, we'd have someone pretty much stand in one location and take a multitude of photos. So imagine that you're trying to pretty much stitch together photos, but in a 3D manner. And so what we would do, and I give an example, we have a cast building, what we call it. It's the concrete science building that we work with. And someone asked me to go scan it. And so my first thought was like, okay, maybe we'll use the 3D scanner. But we ended up doing photogrammetry in this instance, and we took, I think, about 7,000 images of the space. We brought it into reality capture. And what that software does is it starts to look at those images. It starts to correlate kind of key aspects of it. So it says, okay, I know that that corner is there. In this image, that corner is there. And it starts to take all of those images, form them together, and it actually allows you to create a 3D kind of representation of that space just using 2D images. And if you start to take that even further, you can look into technologies like Gaussian splatting, which is something that's becoming more and more popular and something that they've actually done a workshop here at New Media Manitoba about. And that again takes that idea of kind of still 2D images or video and turning it into a 3D environment, which to me I think is very exciting, and especially for the younger generation who's starting to work on different types of forms of art and trying to actually, try to find themselves in this world. I think that it's absolutely beautiful.
Fantastic. So we've made some references to some different projects here, and I know we have some images to help to illustrate some of these projects as well. So maybe Chris, I'll start with you. If we can load up the first image here on the screen, if you can share with us more about what you're doing in the ag space.
Great, thank you. This is, so our research group does three things. We create labeled data sets for machine learning application and we share them. We develop machine learning models and we develop automated methods for collecting data. So Jason was just talking about photogrammetry, and so I included this here. I think if you hit the right arrow, the animations will start playing. Oh, maybe not. Okay, if you could go back. Well, there's two animations here, actually three. But what this is a photogrammetry system we built in our lab. It has 4 cameras. You place the plant on the turntable and it will rotate a certain number of degrees. And then you can take these images and that are just 2D, and you can use something like Gaussian splat that Jason mentioned, structure from motion. Now there's also neural approaches that can take these 2D images and they can make them into point clouds. And if this animation in the bottom left was running, you would see the wheat from all sorts of different directions. We use this for agricultural applications. This is a phenotyping application, but you can use it for all sorts of applications that we'll hear today. And then the next 2 slides are just examples of machine learning applications that we've developed in our lab. This is a particular type of application where we take a laser scanner that will then also produce a point cloud, and we use it for detection and assessment of Fusarium head blight, which is the most one of the most severe diseases for cereal crops. And the best resistance is breeding resistant strains of wheat. And so we develop these sort of applications to help experts in their area expedite their research. And should be one more with a video on it. Okay, well then to be continued. If you want to actually see them, you can contact me after and we can see them live later.
But maybe continuing on that, I know, Chris, you'd also mentioned using AI when you have able to train AI to then transform low resolution images into high resolution. If you can share more about that.
Sure, yeah. So that process is called super resolution. So it exists for images, and that's where it's most popular, where you take a low resolution image and you can increase the resolution maybe by a factor of 2 to 4 times a high resolution, maybe 5 if you're lucky. And one of the things that we're doing is working with digital elevation models. So going back to the LiDAR discussions that were held earlier. So the federal government, they have tons of low resolution digital elevation models of Canada, and they want to produce high resolution versions of these digital elevation models for all sorts of reasons, but to provide for businesses, for other government departments. So we're developing machine learning algorithms that will take the high resolution algorithms and learn to downsample them to then create a data set that we can use to develop a different algorithm that can learn to take the low resolution digital elevation models and make them the high resolution digital elevation models. And maybe we'll come back to this later, but we can use machine learning to these generative methods to create data to develop other machine learning algorithms. And that's a huge part of getting at these data sets that we need.
So Chelsea, moving over to you, if you can share with us more about projects in your space. I know we were talking about LiDAR and construction.
Sure, and I'm going to hit 2. Again, super boring, right, Chris? You know, I love when people get really in the weeds because all of a sudden I bring this up here because I know I'm going to take a note. Oh, I didn't ask him about this, and then obviously dig into it later. But I'm going to start on the fraud side because I know we've gotten a lot into transportation. I don't know about the rest of you, but have you experienced identity theft or anything with the fraud? Yes. 1 in 10 people have actually experienced identity theft. It's a massive, massive problem. It drives me absolutely crazy. And to date back in the military, I was actually a finance officer. So deploying to Afghanistan, my job was to convert the entire cash-based system to electronic funds, meaning I'd walk up to an individual and say, can you hand me all of your cash? I'm going to give you this sweet piece of plastic. Yeah, exactly. Did not go super smooth. And then I was counting on the interpreter next to the individual to say, can you tell him that? And he'd give me that look of like, not only am I not going to tell him that, but you're crazy, lady. But needless to say, on that side of the house, got a lot of exposure to fraud, unfortunately, and came back with a big passion to help the financial industry. So what we're doing, leveraging AI, is basically tracking normal versus abnormal behavior and then trying to triangulate so that we can, again, create this structured data we're talking about, capture those patterns and trends, and then, frankly, stop fraud from happening. Now, some cool developments that we've leaned into are some of the tools that have developed out of the deep and dark web that essentially they'll do the religious scans. You've got the human in the loop that can communicate in the language of which the deep and dark web, perhaps Telegram channels, are communicating on, and then bring that data together and say, these are compromised instruments, whether they're checks or your credit card or debit card. How do we stop them from being used? And then how do we stop the check from being cashed? So very interesting. It's actually led to some great results in terms of stopping check fraud as well as credit and debit card fraud. We even have a new technology coming out that replaces your current magnetic strip, how you've got your magnetic strip for a tap to pay. The 16 digits on it are different than the printed ones. So that if you actually have a skimmer that grabs your 16 digits off of whatever, a flipper device or something of that nature, if they go to manually enter those 16 digits in, it's actually different. So we know that that is a fraudster trying to use a skim device. So lots of things going on in the fraud space relative to AI. And then putting on the transportation hat, coming back to the drones, I think we've got a couple of videos here relative to the scans we've done. And I don't know if mine are videos either, so we'll figure it out here. Oh, beautiful. So this right here, this is a rough cut of a point cloud. And I'll say it came directly from the drone itself. So what we did is take this scan, and anybody fly drones in the audience? Okay, so a couple pilots out here. Any scan you're doing, that if it's, I'll say a slew of acreage, it really takes exponentially less time. So normally this scan, or a scan of this size for a surveyor would take roughly weeks. This one took us 38 minutes. So scanning something to this size, you bring in then the data and you process it. This is what we're doing inside of Unreal. And what I like about Unreal is, again, going back to my kids, it's the same folks out of Epic Games that built Fortnite. So if I can tell my kids, hey, jump into Fortnite and you can play the scenario, then take something like this, which so happens to be a construction site in downtown Cleveland, and say, jump into this environment and plan your site, what would you do? You can get exponentially faster results and more creative thinking. And then on the flip side, right here, I can add imagery. So New Media Manitoba has done a fabulous job of adding imagery that didn't exist, allowing you to jump in, operate the heavy machinery, and then lead into additional scenario planning. So let's assume something goes right in this scenario. What would you do? But on the flip side, what if something goes wrong and it turns into an emergency scenario? And we ask that quite often because if this were to go wrong, how would you handle it from a construction angle? But other use cases for drones is called DFR, which is drone as a first responder. So could I deploy a drone in a box to respond to that scenario and actually help an individual in the event it's a true safety scenario? So this is one example of the environments that we've created. It's definitely going to be part of the course that starts Wednesday. Small plug if you want to get involved. The next one, I believe, is a part of NASA. So right outside of NASA is where I actually live. And one of the issues is they have a variety of properties that are protected. So to get the clearances to actually fly that airspace can be difficult. And this so happened to be one that we flew. And they're building different hotels in these respective areas because they're trying to repurpose the aging infrastructure. So doing the scans to then say this is an opportunity and then allowing the students to function off of those scans, we're building that mindset of development and architecture and design all in one space while being creative about scenario thinking and things I previously mentioned. So lots going on in the drone connected to the AI, connected to the visualization and 3D modeling world.
Excellent. Thank you so much, Chelsea. Sean, we'll go over to you if you can share more about your work and how you're applying AI.
Well, to be honest, we struggle with certain applications of AI. To go back to what Chris was saying, a lot of the large language models and other things going on in the background, they've been trained off of a lot of data from the internet, a lot of freely available information. But when it comes to buildings, that information isn't readily available. So we struggle with working with 3D and how we design a building. We usually render it down to a 2D representation, and then we can use generative AI or generative tools to help us optimize a floor plan for life safety, for fire safety, things like that. We can integrate those types of tools. But we do a lot of work with LiDAR as well. It's become a really valuable tool for the visualization side. It used to take a lot of time and effort for me to take a building that we wanted to build and then recreate the site. But now we can send a drone into the air for a few minutes, bring it back similar to what Chelsea just showed you, and plop our model right into the site, nicely meshed with photo textures, and it's really, really powerful. It's completely changed how we're able to visualize a model for our clients, whether they're large scale or small scale. It's been revolutionary.
And can you share more about opportunities in using Unreal? Like, are there reasons why you feel like Unreal is a right fit for some of these visualizations?
I mean, it's super customizable. There are a lot of other tools out there like Enscape and Twinmotion, which is built on Unreal Engine. But for somebody like me, I always reach the point where Revit or Enscape or Twinmotion have put some kind of wall in my way, and Unreal Engine is this completely open-ended universe that you can build anything in. You can take your model and you can make it interactive. You can have all the doors opening. You can be modeling a theater. I've done this. It was not required of the project, but I certainly had a theater project where at the time I put the VR headset on, hit the button, and sat down and watched the Avengers Infinity War trailer in the architectural model. So you get to do some fun things like that. And honestly, you get the right client, they find that fun, that stuff fun too. We have been building custom houses and cabins where we've been able to take LiDAR scans and put our building information model right on the shore so that they can sit in their future living room and be able to look out upon the vista that they're actually going to have. And we can actually then utilize our design tools, adjust the windows, adjust how things are aligning so that they get exactly what they're going to get well before they're actually sitting in there and unhappy with the giant window mullions that are now blocking their beautiful lakescape. So it's been just completely changed the game for us.
Absolutely, thank you. And Jason, I know we got some images up here for you as well, so I'll pass the mic to you.
Great. So where's our first one here? Let's start off at JS01. Go 2 back. One on the top there. Awesome. Okay, so I want to talk a little bit about this project that I've recently been working on with a multitude of students over at the University of Manitoba. And to give a bit of background and context to the project, just about 100 feet that way, there's a large wall I'd mentioned earlier. And within the context of Winnipeg, this wall is kind of up in the air as to what's going to happen with it. There's been a lot of talk about the closure of Portage and Main, the underground concourse, ever since that the upground concourse, as I call it now, the walking area has been opened. This space down here is getting a lot less traffic and a lot less attention. And so what I initially heard about was that they were going to be shutting down that concourse. And to me, I immediately questioned, well, what's going to happen with this kind of iconic artwork? To me, preservation and archival of these artworks is very important. And so I contacted the city. I didn't really hear anything back. So I eventually contacted the widow of the artist and I said, hey, I think this needs to be 3D scanned. We need to find a way to archive this, and we need to find a way to be able to share it with others. And she was very responsive in that and said, Jason, I absolutely agree. Here's the copyright of the wall. Let's go make this done. And so she was completely on board with this idea. And so what we did was we first and foremost went and did a little bit of background research. We tried to figure out how the wall was built, because anytime I try to go scan anything, I try to understand what it is beforehand. I find that to be a very crucial aspect. And so as we started to go through this process, we started to find out that it's really hard to get architectural drawings and information on that. And so there really wasn't much. And that kind of became the starting point, is how do we begin with this? And so we began with the 3D scanning process. And maybe if you can move to the next slide, please, John. And I think this image is really helpful for people who have maybe not seen this before. And so as you can imagine, that wall over there, it's in a big circle. Each one of these blue dots that we took here, that represents just one of the scans that was taken. And what I think is interesting about this image in particular is AI played a very crucial role, actually, because each one of these scans is tracked in live time. It's called something called VIS. It's pretty much a field visualization software. And by using that, it shows you where each one of the scans occurred, and it actually makes smart decisions on its own to connect those two scans. So similar to what I was saying before, it's this idea of stitching all of these 3D scans together. So I didn't go and just do one. I went and did 28 of them. And in this instance, the AI took these 28 of them, connected them all together, and it did a pretty good job until I got back to the office, and then I had to shift a couple around. So kind of this idea that yes, AI is our friend, it can assist us in the visualization, but without having that foundational knowledge, I had to manually kind of go in there and fix a couple of things. So it's not perfect by any means. If we maybe go to the next slide now. And so now it's been months and months and months, and we've been working on getting this into actually Unreal Engine. And so this was the initial, we initially took the scan as a point cloud, and we were talking about that before, and point clouds are usually shown as just a multitude of small circles. I believe the initial scan we did consisted of 340 million points. And so if you try to take that many points and try to put it in a video game, it's not going to work. So we had to go in and we had to what we call decimate the wall, in a sense. We had to go in and we had to shave it down. We had to break those points down, and we had to make it into something that was viable. Again, in this instance, AI played a very large role. The large language model in the background was starting to make a lot of decisions, and some of those decisions, in all honesty, were not exactly what we wanted. It started doing what I kind of called cultural erasing. It was taking something that had existed in the past, and the AI started to fill in some blanks, saying, well, that's not a whole, maybe it's this material. And that got me a little frustrated at times. And so I had to step back and I had to kind of do some manual working. And then I came back and I used that kind of large language model again. And once I had that knowledge of what I wanted to do, it was able to really kind of refine it and fix it. And we've been still working on this to try to get the smoothness down. It becomes very difficult at times. And so that's been one of the large challenges of working with AI and working with these 3D scans. And then we began to augment it with images of the building of it, of old news articles. And so what I'm really getting at here is that 3D scan that we created, yes, it was supposed to encapsulate the art piece, it was supposed to conserve it, but now we've actually created a whole new experience through that. And now people are able to go experience this. They can experience the real one right now. I'm not sure for how long, but they can also experience the past, and they can experience how it was temporality in that sense, because each one of these scans takes a snapshot of time. And if I were to come back 10 years later, that scan could change wildly. And I think that's something that really interests me about this project. So yeah, thanks for letting me talk about that.
Absolutely. Yeah, thanks to each of you for sharing about some of the projects that you're working on. Are there any other areas that AI can be used in that we haven't discussed, or say like applications in different sectors that you think would make sense to highlight here?
I can't emphasize enough just youth curiosity. And I know the last panel spoke on it a little bit, but too often we stifle the youth in terms of thinking this is the pathway to where you will be most successful. And I'll say that over the past really year, I've done a lot of research in terms of youth education. By no means am I an educator or an expert. I'm just a parent attempting to do the right thing. So I will not claim expertise in any capacity. But I learned a lot about how this generation has been trained not to feel stupid. And that word's been passed around pretty often in that, what does that mean? Are you stupid, and what does that feel like? And I felt very insulted initially. I was like, daggone, what are we talking about? Well, what it meant from that piece of research was that we as a generation, the baby boomer, et cetera, and even the early stage Gen Xers, I'll say, reached out and were okay by saying, hey, what is your first name? I don't know what this means. Can you point me in the right direction? Or during employee training, we're willing to reach out and ask those questions. You've been here for X number of years. Can you teach me how this works? And then go back to, say, AI models, plug it in and say, where's the most recent SOP, and is that really how we do it? Kind of what the last panel said. And then bring that up as a tabletop conversation. Well, that idea of being stupid is where this next generation doesn't conform to that style. If they have to ask up front, that means they haven't used their resources to the best of their ability. And that took a minute for me to embrace and say, oh, okay, I get it. So they actually would rather not ask. They'd rather ask a device, be given some of the answers, and then lean into it as a practice. And I thought that was interesting, especially relative to some of this tech and off of the projects each one of us have shared, that it's very easy for me to hand the sticks for a drone to a kid and say, hey, go fly. Whereas I hand them to an adult, and it's very uncomfortable for them. And the same is true with AI. Regardless of the tool that you believe is the best, they'll type in real quick and then hope they did the right thing, but at least it'll spit them out an answer. Whereas we're a little bit hesitant because we start to question the data and the integrity of it and who has access to it. So I'll say from a real life scenario, where could we use it more, is throwing our kids into the mix of it, especially when we've kind of taste tested it, for lack of a better word, because that's how they learn, and that's what they've learned to appreciate as a way of getting immersed.
Yeah, I definitely agree, and I don't know that area, but it's I definitely agree with it, and I present like a different an example of where we are using machine learning or artificial intelligence, and it's not something that everyone thinks about. So we heard in the last session a lot about you can use these large language models to create images. There are actually different models in the background that are creating these images, but if you go onto ChatGPT and you say, like, give me a picture of a panda jumping on a beach ball, you will probably get something that's similar to what you want, or you can give it some more prompts and you'll get what you want. But if you're trying to use machine learning algorithms to do scientific applications, or work with drone data, or any of these niche areas, we don't have foundational models for these problems yet. So what does that mean? So when you use ChatGPT, you can ask it to make a recipe. It may or may not be good. You can ask it to edit your report that you need to submit. You can use it to brainstorm ideas. So you can use it in all these different applications, and that's what we refer to as a foundational model. And so when you want to solve a different type of problem, so for instance, like with computer vision or some other type of data that we don't have a ton of examples for, we don't have a foundational model for that type of problem solving. So what does that mean? So like if you're working with images or video, so far, it might come in the near future, we don't have a model where we can say, take this video and do X with it, and then do Y, and then do Z yet. And so if you want to develop a solution for a very specific application, we can use machine learning models to generate this data, these generative approaches. And we can take a little bit of data from the real world that's maybe expensive to get, and we can use it to generate new examples so that we can then develop another machine learning model that solves the problem. Because if we work with agricultural data, for example, we can't just scrape a lot of that off the internet. If you work with these highly specialized problems, you can't scrape a lot of that off the internet. So that's another area that people don't think about, because it's not like the sexy part of doing machine learning where you're creating and labeling data, but it can help alleviate that problem as well.
Just on the note of specific data, one of the applications that we use at Republic is actually in translation. We have to create drawing sets and construction specifications that are both in English and French. And while they tried to teach me French, it didn't take, and I'm an ignorant English speaker. So we only have one person or two people at Republic that actually speak French, and they will attest to the fact that if you try to take a construction document and put it into a translator, whether it's AI powered or not, it's not going to know what to do with the architectural and the structural and the engineering speak. So you're going to get something that common one is in architecture, we're always talking about elevation, but half the time that was translated to altitude, because it didn't know the context of what it had to translate. So we have manually translated things and started using Azure's custom translator to start teaching and training for fine-tuning our own AI model based off of our translation. So it's leveraging the large language models that have already been created, but then trying to fill in the gaps of where it's getting things wrong. And so that's probably one of the biggest things that I've been working on recently, is trying to create a data set that actually works for architectural and construction uses.
So playing off of that, as Chelsea had mentioned as well, on artificial intelligence, that data is the first point. That's important, that you have that quality data, that you're cleaning the data. So in that way, I'm interested in going a little bit deeper around, I know, Chris, you were mentioning too, on the structured and the unstructured, of like, how do we make sure that if we're interested in developing or implementing new AI in our areas of work, that we do have the right kind of data so that we have these tools that are trained properly?
Creating data is, definitely the most costly and time-intensive part of it, and it's really easy to create bad, terrible data. And then once you do, you're going to spend more time and money, fixing that problem afterwards. So before you even go about creating data, or I guess take a step back, you want to develop a machine learning algorithm. It's not using pictures of cats and dogs, so you have to then figure out what's the data set you're going to use. Before you go out and just create a bunch of data, you need your data management plan, and you need to really think carefully about it, because you might go out and create 10,000, 100,000, a million examples of that type of data, and if you don't have it well structured, and if you don't take the metadata that you collect with it, when you there'll be like your imagery that you take, and maybe there'll be information about the imagery, and that's called metadata. If you don't have that all organized ahead of time, you're going to have a real nightmare afterwards. So I would say you want to do a lot of planning and carefully thinking things through before you just go out and start creating and collecting data.
I'll add having the subject matter expert in the room as well. And I know the last panel spoke on that, but too often we overlook the players that all have a specific role. And if you put everybody in the room at the same time, there's different leading and learning styles. There's also different experts in the room. And I always compare it to when you bring on new technology, and I specifically speak from the finance sector, a core processor drives everything you do in the financial world. So that core processor houses everything, all the APIs feed into it. Well, the IT person that is doing a core processor conversion in certain instances, they have no idea what a loan looks like when it's actually being processed and transferred from one piece of technology to another. They're counting on that loan department to say, this is a perfect outcome. The name goes here, the social goes here, the supporting documentation. That IT person would never know. So by having the loan expert involved, at that point, you're giving the correct information to the person that is putting the whole thing together. So you can have a data collection plan, which is fantastic, but having that person and keeping that human in the loop as the experienced professional that knows what right looks like or perhaps speaks French, that individual is still paramount, and making sure that you don't just overlook their role is critical to success.
Maybe I'll add just a little bit to this as well in terms of the data collection. I showed that example there where I had about 28 scans from that Bruce head wall. I also took on a large project where I was scanning a large chunk of the spaces in the University of Manitoba. And so what ended up happening was I had about we'll say 55 rooms worth of data. Each one of those rooms have 7 scans in them, and I did have to kind of figure out a structured way as to how to approach that. And the first thing I did was I kind of looked at ISO, ASTM standards and started to look at how are people typically storing three-dimensional data and stuff. And the information I found was arguably so outdated and like wasn't completely relevant for what I was doing, is that I had to build somewhat of a structure built upon that. And so how I at least approach it was I looked at some of the foundational aspects of aligned or other disciplines that were using 3D models, and then I kind of applied it to an architectural standpoint, because as Sean would know, in architecture we have a very kind of rigid system in which we go through schematic drawings, design development, and working drawings. And that's just the system we work at, where a drawing's at 33 versus 66 versus 99% complete. And so using that kind of idea as the, well, at what point is this scan done? Was it done at 33%? Did I have to do something afterwards with that? And so actually organizing it all, because once I had to go back to it, and once my research assistants had to go back to all this data, she was pretty mad at me. And it was exactly what you had said. I gave her bad data. And, well, maybe not bad data, but I did not give her a good time. And that actually taught me a lot that day about how I should be structuring those things. And ever since then, I literally have a book now in which I give any of the students I work with or RAs I work with, and I say, this is how you structure that data. And that book is always in flux. And so when someone comes to me and says, I'm not sure if this makes sense, I think you have to have a bit of flexibility, because when we're working with these new types of data and these new types of AI, we don't always have the answer to it. So sometimes I always say, do your research, best step forward, and then begin to adapt it to what you need. Because if you just take that basic answer that the AI is always going to give you, and it's always kind of a bit of a yes man sometimes, so you always have to challenge it, I find. And that's what I learned, at least through experience, when trying to organize data, is do it good from the start and actually have a real structured plan after you've kind of messed it up a couple times.
And then he takes the book, he puts it in AI, talks to AI and says, this is what we're doing, update the book. Every week, right?
Absolutely. So continuing on the discussion with data and how we're storing it, wanted to also touch on, say, like the privacy aspect. I don't think we need to go too deep, because I know that was covered the legal side quite a bit more in the earlier session. But when it comes to, say, that sovereignty, where the data is stored, what are things that we should be keeping in mind?
And I am by no means even close to a lawyer, so take this for what it's worth. But on the cybersecurity side, I'm big into cybersecurity, and we often overlook access controls. And that a majority of us, and especially if you're a smaller firm, and I'll say under 25, that admin role associated with most tech, it seems to be a bit too universal. And the same is true when it comes to all this data. We've mentioned millions of points and different points, different numbers throughout this entire panel. That's a lot of information that's in somebody's hands. And when we have universal admin controls that are out there regardless of the system, right there in and of itself is overexposure. So I would say treat the data you have from a cybersecurity angle as being heavily protected until you know how you're going to structure it, who should have access, and frankly, what privacy laws you could accidentally break just because you frankly didn't know and too many people have too much access.
This is an area I don't have that much experience with because most of the data we make publicly available or open access. But I do work with some companies that want to keep their data private because it's the most costly part of the machine learning development process. And yeah, I echo what Chelsea said. It's just something you want to take account into at the beginning of the project and talk to people who actually know the ins and outs of the legal side of things and the tech side of things.
So this is something I have to deal with all the time. Republic works primarily with government organizations. So any single time we're dealing with any type of data, we have to provide assurances to their security departments that we're storing our data on Canadian data centers. But unfortunately, to pick on one of the panel members here, we have to worry about who owns the data as well. Because although we might work with Microsoft and say that it's stored on a Canadian data center, there's the glaring issue of the fact that through the Patriot Act, the United States government could access an American company's data regardless of where it's stored geographically. So there are no solutions to that other than for Canada to start investing in its own data centers so that we can actually store this data locally in Canada, owned by Canadian companies. So that's something we're always thinking about. And even then, it comes down to the nature of the data that I'd be working with. How many of you would be willing to take a 3D model of your home and throw it out in the public so that an AI model can learn what a building is? It's going to be the same with the government. It's going to be the same with Canada Life and any other big company. They're not freely going to offer this data. So it's going to be challenging to build large language models isn't the right word, but it's going to be hard to build the data sets required to really work towards something like automated e-permitting and understanding what, does your building meet building code and things like that, because even our codes are not well digitized. The NRC, the National Research Council of Canada, is working towards a digital platform that digitizes codes, provides tools for carbon emission reduction and things like that, but those are still a long ways off, and then we have to integrate them into our practices, and governments have to mandate these types of things. So, I mean, I'm going on a tangent here, but yeah, there's lots to deal with.
Absolutely. So we're coming close to time here. If you have any questions in the audience, we'll give you an option as well. But I'll ask one more question here around the future opportunities of what are exciting developments that you're seeing, or what are you hoping to see as future advancements in AI?
I'm really scared of the mic. I'm sure you can all tell. So you bring up a great point on data centers, because data centers bring up another area of opportunity, and that's really where we've immersed ourselves right now, and that's on energy. In that data centers, along with AI, along with any of these advanced technologies, all have a very, very heavy energy pull. And so the opportunity exists right now to explore what energy exists from different sources, be that hydrogen sources, if that's a power juncture, if that's another behind the meter grid, which is a lot of the work we're doing stateside, is to identify more of those behind the meter grids and different technologies that can feed to them, one of which is a waste to energy initiative to basically take municipal solid waste, use a pyrolysis process and turn it back into energy, which then the municipalities can buy back. And then that creates additional opportunities for AI and technologies to thrive. So I would say a lot of the opportunities is to put on the supporting infrastructure hat and find out if these technologies are going to be the next wave. And I forget what the previous panel alluded to in terms of them being equivalent with energy. That if that is the next wave, what other infrastructure opportunities exist around that, and jump in. So happy to elaborate more on the energy stuff, but that's where I would say there's tremendous opportunity.
Thanks. Yeah, I agree on the sustainability side. It's not my area, but someone in our department works on that. And machine learning uses a lot of energy. These data centers, some of them are clean energy data centers. Some of them take their energy from coal burning, electrical generation. Um, and the actual workflow and the computation is different for machine learning computation versus other approaches. So that's one area that I think there's going to be lots of innovation is on the hardware and the data, transmitting data between these data centers. How can we make it most efficient and low energy use for transportation and distribution of data, and then new hardware that runs with low energy consumption. And then the other thing another area that I'm excited about is, like I mentioned earlier, that I work in agriculture, but you're going to see this, and you're already seeing this across the board, where these machine learning algorithms they can't solve every problem. They can solve specific problems very well, and they can help accelerate and expedite different areas of research and industry. And that's happening for agriculture, like for the sustainable intensification of prairie crop production. And you're going to see that across all these disciplines, so whether it's medicine or finance. And I think that's going to be pretty exciting, where we look to see where these specific machine learning algorithms can help us and free us up to be more creative, focus on problem solving, and remove all the tedious things that humans aren't really that good at. So that's my vision for the next 5-10 years.
Touching quickly on sustainability, I think this is one of the biggest resistance points that we see. I think Jason and I were talking about this. There's two main points that people usually say, like, oh, I don't want to use AI on principle. And one of them is sustainability and just how much energy it uses, how much these data centers use. But to tie that into the future, I start to think about, how can this computation heavy process be used to help design better data centers? How can we optimize our buildings, our mechanical systems, our electrical systems to reduce demand, combine it with optimizations to the algorithms? We have to be pragmatic here. This is the new electricity. It's not going anywhere. And so rather than trying to fight with it and hold it off, we need to worry about how we work with it and make it more sustainable. That it's something it's going to happen. And one quick future note as well. I don't know if anybody has ever seen what they're doing at Parliament Hill in Ottawa. They're actually trying to fit a 3-story building underneath Capitol Hill, or not Capitol Hill, Center Block. Sorry, and every single week, the construction companies there, they send a drone up in the air and they site survey the whole place. And I'm looking forward to a future where we can almost automate that process and use it to monitor construction site safety, life safety. They've dug 3 stories into the ground in rock. Are there algorithms that can identify, okay, that rock isn't looking very good anymore. We need to start worrying about whether it's going to collapse and what we need to do to work with it. I do a lot of award reviews, and every single year I see really interesting projects for site monitoring. There have been times where people's lives have been saved because cameras are monitoring job sites, and they can identify when somebody hasn't been moving enough, or they are in a position that is not natural, and they can immediately flag it to the site safety, and they can respond and save that person's life. People have had heart attacks in tanks and things like that. So whether it's visual monitoring or simple monitoring of devices on their bodies, it can save lives. So there's lots of potential there.
Yeah, so I guess to reiterate what Sean was saying as well is, at least on my end, I've had quite a few people, and both me and Sean come from a kind of a creative discipline where I'd say it kind of mixes this idea of creativity within architecture as well as technicality. And we were talking earlier, and we're finding sometimes a lot of creative people are like a little more against AI than technical people, and I've been finding that very interesting for some reason, because I just didn't expect that. And so what I've been repeatedly told is, yeah, AI is not sustainable, you shouldn't be using it, so on and so forth. And when I always kind of question or scrutinize that a little bit, and I say, how did you get here today? And they look at me, what do you mean? I'm like, did you drive? They said yes. Well, I took the bus. Does that mean I get 100 more prompts today? And so like we kind of have to like pose about it as like how are we as a human going to be sustainable? Not as how is AI going to be sustainable? No one's asking is Google sustainable anymore. Sustainability should inherently be a part of our lives. We shouldn't kind of be calling people out on it necessarily, and we should be looking towards a solution. And that's why I thought was really lovely the way that you posed it, is actually using that tool to create the solutions for the problems that it's created. It becomes in almost a cycle. It's like, okay, we have AI, but sustainability is the problem. All right, let's use AI to solve sustainability. And I think that's actually a feature of it, which I think is quite lovely. And so to answer the other question, which is what am I excited about, I want to kind of tie on to what you said before, which is this idea of childhood wonder. And because we come from a creative background, and we often hear people talking about, okay, AI is going to bring me this much ROI in my business. It's going to be able to do this. What I'm really excited about is this idea, and I mentioned it the other day, is that OpenAI has ChatGPT. Well, that does their tech stuff. And they got Sora 2 now. That does the video stuff. But years ago, they started something called Pointy, which was to actually generate 3D images and 3D models. And so that's where I'm starting to get kind of excited, is this new idea is that I could just generate unworldly 3D objects. I could bring that unworldly 3D object, bring that into the Bruce Head wall, bring that into your piece, and start to be a bit more creative with it as well, because I think often we look really inside the box as, okay, what can AI do? How can that help us? How can that fix that? I'm not really trying to get help or fix anything in this instance. I want to kind of play around. I want to explore. I want to be creative. And that's something that I always encourage a lot of my students and people to think about when it comes to AI. No, it's not going to it's not the most creative tool in the world. It's not going to replace me drawing something, but you can do some pretty cool stuff with that. And I think if we come in and think that, it's not a very creative tool, well, then it's not going to be a very creative output. But if we think about how we can actually play with it, modify it, play around with it, hack it, chop it up, that's where I start to get really excited, because I see so many different opportunities through that. And that's where I kind of see the next kind of 10, 15 years going, is not so much more that pushback that we had on creativity, but people learning how to embrace it in the creative workflow and use it effectively.
What a wonderful way to end our formal panel questions here. Opening it up to the audience, because we do have the 2 microphones here, if you'd mind just coming kind of up to the front to ask a question. Any questions from the audience here? Yeah.
Hi, so it's more on topic with what you just finished with. We're both educators, K-12, and so if you think about thinking and how we think about thinking, what is your projections for K-12 to be, to have the skills and competencies to actually embrace what is coming in the next 5 to 10 years?
You got the kids.
Yeah.
I got no kids.
Still a parent over here. Was very proud of myself. I waited until my oldest son turned 14 before I got him a phone. It was the proudest moment of my life. Like, I made it till 14. So I will say, just to phrase your question back, to what do we need to teach, or what's the...
I guess the process of thinking about how we think, AI is going to shift how we think about data and how we think about our daily lives.
Yeah.
And education right now is built still, even with new curriculum, on what was happening 5 to 10 years ago, not 2 years ago when AI
Yeah.
was developed and released, or well, just released. So what needs to shift in how we think and get to skills and competencies that kids are going to need when they graduate? If they're in kindergarten today, graduating in 12 years, what do we need to teach them?
Point blank critical thinking. And I can't tell you, even as our company grew, it's just one of those when you look at kids anymore and say, here's the problem set, here's the answer, what's next? That ability to critically think beyond the obvious answer is what needs to be trained. And I'll tell you a model that we've brought into our school systems and I've really enjoyed. On one side of it I have, the other side I haven't so much. Every kid gets issued a Chromebook. Which to me, initially, I was like, you've got to be kidding me. You're handing my kid that can't take care of a stuffed animal a Chromebook. So needless to say, that issuance of a device instantaneously with the protections it deserves, I think was step 1. Once that became universally embraced, now this year they've rolled out different electives that I really appreciate. App development, coding robots, connecting drones to the robotics. They're actually having the kids create the lesson plans using AI. and then adding the questions around that. So they're leveraging the technology in the classroom to say, now you must critically think about what you will need to know for the next step in life. I've absolutely loved it because we can have real conversations rather than dodging the bullet at the dinner table in terms of, hey, don't use AI or I can't help you on that. It's, hey, I used AI, it came back with this, that doesn't seem right, and how did you use that in real life? It's opened up a whole new world of a different type of creativity around critically thinking.
Yeah, maybe just to add to that very quickly is, yeah, critical thought, I would say, would be one of the most crucial things. And also, I would say, pushing them to use it when maybe they don't even think it's appropriate. Every once in a while, I'll be working with the student, and I'll say, well, why don't you check that out in AI? And they'll look at me like I've told them the worst thing in the world. And I kind of look at them like, well, what's so offensive about me suggesting that you use that? They're like, well, it doesn't seem appropriate, Jason. I'm like, well, what's appropriate? Like, and so I think maybe lowering that barrier a little bit as well too, because what I've been finding is a lot of them say they don't want to use it. Maybe that's just to me because I'm in a position of power and I'm giving them marks. I'm not too sure. But a lot of them are just kind of, no, I don't want to use it. That's not what it's for. And I'm like, well, this kind of is what it's for. And it will save you hours of work here in this instance. So I think just letting students know that don't cheat, be ethical, be reasonable, but use it past its boundaries. Use it past what you think you normally should. Like, you shouldn't just be asking it to rearrange your grocery list for you. You could probably get it to rearrange your grocery list into anagrams. But like, and so you just want to think about the other ways that you can use it and leverage it.
Yeah, and so I agree with the panel. The kind of question falls into two parts. So there's the usage part and getting kids access to it, like Chelsea and Jason mentioned, and then using it the way it was developed and using it for different approaches. And on that side, I think China is doing a big push from K to 12 to integrate AI into like every aspect of the classroom. I'm not certain that you want to put it in every aspect, but definitely getting it, people using it and seeing, what they can do with it is a huge skill. At the same time, the countries or the societies that prioritize AI in the classroom, I think, will start to win the AI race and maybe the other races. But you also have to create these algorithms. And so you need that aspect too. So right now, the skills that you need in order to develop these algorithms is you need mathematics, you need probability, and you need software development. So you need to be good at using it, and then we also need a lot of people that can be hired that can create algorithms or know how these algorithms are running in the background, so that when a company or startup says, I think I have this great idea to use AI, but there's nothing off the shelf, no product I can buy to let my company do that, well then there's a workforce that is trained on how to actually create machine learning algorithms from the ground up. So we need to be users and we need to be creators of AI on both sides.
I'll be the wet blanket of the panel and say that we have to be aware of the biases in these algorithms as well if we're going to put it into the hands of educators, because there may be underlying things that we don't know, the impressions that we could be giving K to 5 or 6 students. So it's something we need to be aware of as well when we're dealing with education.
Yeah, excellent point. Another question from the audience? Yeah.
I mean, feel free anyone to answer, but I guess kind of pointed at Jason when you're looking around the creativity piece, and going back to where Chris is saying that you need to have data. I'm thinking like as a use case, as an example, music. People are creating AI music, and I have to think as an artist, you have to probably hate that your work is being used as training data against your will probably, but yet some people are doing some pretty creative things with it. So how do you reconcile that?
That one's a tricky one for me because I used to do a lot of music production. And so when I kind of look at that in a sense too, it's hard because a lot of people out there are sampling music. A good majority of how hip hop functions is the sampling of other artists and taking that and then recreating it into something new. Of course, that has the human touch somewhat in it, whether that be through the drum machines or the synthesizers that are overlaid on top of those samples. But really, they're taking something out of thin air and they're starting to build upon it because there's a human behind it, and because there's something that's I'm going to argue been socialized to be sold to you. Does that make it better? Maybe.
I was going to say, don't most of those artists also have to pay copyrights to those previous artists, though?
Sometimes they do. In hip hop, notoriously, they haven't. There's one actual drummer that his drums have been sampled over 10,000 times, and he hasn't been paid a cent. So he kind of maybe falls into that category. But I think it is a tricky thing. I think the biggest problem is that idea of when we listen to music and we listen to art, we often connect it with an individual or the creator. And so, you can have someone walk out and make some really wild film, but if it's not by David Lynch, it's probably not David Lynch, you know what I mean? And so it's that idea of the aura of the artist and the soul that goes behind it, maybe the story behind it as well. What you're seeing now is, though, that, yeah, AI is creating these artists, creating the story behind it. And I don't know how people in the world is going to kind of respond to this. I know that people from my generation are all totally against it. This is the worst. But then simultaneously, I come back and I think, well, a lot of the music that I grew up on, a lot of the music I love, that is just reincorporations of other old music. And just because this person who looked really cool or that I was really into when I was 12 did it, that it resonates more, I don't know. And that's what I think is the big challenge with AI, is that sometimes it makes you look back at yourself and you say, oh, like, do I really know where kind of like my morals stand on this? And I think as it gets bigger and bigger, and I heard that there's like a country AI artist that's on the Billboard charts now, I think we're going to see it kind of disappear. And so while I am concerned about it, I think it's a crucial aspect of AI coming out as well, because if we can find out that, hey, they can make this art and we don't like it for this reason, well, then it kind of disappears a little bit. And so I think maybe we should embrace this moment of us being not so excited about AI music creation, because hopefully it doesn't stick around, because I don't think it's good, but I don't know if I dislike it. I know that's a very odd response.
I don't flex my artistic muscles very often, but I thought a bit about this, and I agree with Jason's point about the aura of the artist, because I think maybe like a good analogy is modern art museums. I hear comedians make these jokes, or like they go into a modern art museum and they're like, well, why didn't I think of that? Or like, I could have I've done that. But then that goes back to the aura of the artist that's gone through the training and the creative process. And when they create something that you think might be trivial, it actually means something to the community and to the other people seeing it. So maybe AI can make a really good earworm, but maybe it won't be creating like these deep artistic things that we all really appreciate. Right. Yeah.
I just wanted to add to it. So it's interesting because I sort of follow the steal like an artist philosophy, and I think that's been around forever. So why we don't just sort of give up to that and see where it goes, because it's not failed us yet.
I think I probably for Chris. What do you say for someone that has maybe problems? Let's say, for myself, I have a lot of experience like IT support, and I have problem like using AI for troubleshoot. I feel like a waste more of my time using AI than like do it myself. What are your opinions about it? What do you think would be the best approach with it?
Did you say tech support?
Yeah, I do a lot of tech support,
Okay.
so yeah, so I feel when I try to use AI for troubleshooting, I feel like I don't maybe I feel like I waste more of my time than if I do it myself.
Well, that's because you probably have a ton of experience in the area. So it goes back to the critical thinking piece. To use like analogies I know from education, students can put the question into ChatGPT, and some professors get them to do that, or Gemini or their favorite tool, and it'll spit out an answer. But without the years of experience that you have, you don't have the ability to assess whether that's just garbage that got spit out, or like it might sound good, but a lot of times it's nonsense, right? And so your question is, am I wasting my time using AI, or is it helping me? Well, I think that you could probably find some instances in your workflow where it could accelerate and reduce some of your time, maybe as an information aggregator, and then use your experience to determine which of that information is good, which is it's not. I think it's really personal depending on what your daily workflow is. But I think there's ways that it can use to help you accelerate some things, and in other cases, like you mentioned, it might actually take you longer to do it. So that's really a non-answer, but I find I use it in different areas in my life to accelerate things. I can't wait until I can just walk away from email and maybe answer 10% of my emails. But I think, yeah, you got to find what it's useful for you, and if it's not useful, then obviously don't use it.
So I'm going to reference Andrew Ng's course on deeplearning.ai, great course for AI for everybody. He says that when you're dealing with ChatGPT, you need to treat it like a fresh college student, somebody that's going to know a lot about general things, but isn't going to know anything specific about what you're working with. So what really helped me with understanding that is, he said you have to provide a lot of context when you're doing your prompts. So again, if you ask them a very technical question about a specific software or product that you're working with, it may not know how to answer anything, or it may just make things up based on what it generally knows. So you have to treat it like a green college student that's just come into your industry and needs a lot of explaining if you want to get very good specific responses from it. So that's some tips.
One in the back, if you want to come to the front to ask a question to the mic, please.
Hi. I'm very happy that you spoke on data centers because I feel like when we go to conferences like this, it's mostly about the software side, not really the hardware side. So I just wanted to ask that in terms of data centers for Canada, what would you say is the biggest challenge? Is it energy or is it capacity compared to like from other countries?
It's not my area, but there is a researcher in our department that does focus on this. But my general knowledge is we often have our energy in Canada is a lot cleaner. So, like if you are wanting to know about sustainability of online products, like cloud products like Amazon or Google, maybe if you're a big enough client, you can ask them. When you're using these services for machine learning development and then machine learning, I forget the term, but when your product's actually being used by customers, they determine which data centers those jobs get routed to. So if it's a data center that happens to be on Canada and it's powered by hydroelectric energy, then that would be a lot cleaner than a data center that's in some other country that's being powered by coal energy. Other than that, I can't get more specific, other than I think I mentioned this earlier. There is a lot of research and industries that are focused on, and these large companies too, focus on how do we get the hardware using less power, how do we get make our communication within the hardware more efficient and our communication with the user more efficient. And they're primarily driven by financial incentives, because if it uses less power, then it costs them less money. And that's as deep as I can get on that answer.
I'm only going to answer with a shameless plug because I don't know the answers. And so we do a conference every year on a topic that's a hot topic and uncomfortable for most people. Last year was all about how DJI is a Chinese-based drone. How do we get to basically manufacturing to the point where we can build them in-house and then deploy them? This year, energy is our topic. So May 28th, 29th, if anybody's coming to the Ohio area, you're welcome to come. But it's all about energy, the different sources, and we're calling it the quiet giants, because it's one of those where it is a massive problem with lots of solutions that, frankly, people are kind of hush-hush about until voices speak up and say, what are we doing about it?
All right. Well, then, as we're wrapping up the panel here, want to give each of you an opportunity. If there's anything that we haven't touched on yet, or a key takeaway that you want to highlight for the audience here, we'll hear from each of you here. Maybe starting at the end, we'll come back this way. Sean, we'll start with you.
I think I've spoken a lot about the future and the possibilities, and for my industry, it's still relatively early. There's a lot of great models that are out there for general information, but we're still waiting for it to get better with discipline-specific things, and so I'm really looking forward to that future. It's something that's going to change the world. It already is. It's certainly made my life a lot easier already, and yeah, I guess that's all I would just general.
Yeah, I guess just re-emphasizing a few things that I said earlier. One is AI can't solve every problem, so that's a takeaway. I know that sounds weird coming from a person who works in machine learning and AI, but you need to know that it can excel at certain problems. It can do really well, even better than human performance, but others it's not appropriate. And so knowing where where to apply it and where not to. And then the other thing is it's going to cause lots of disruptions, and that comes with good and bad sides of things. I am an optimist, but people's jobs that maybe are tedious and can be automated, that's where we have to help those people and help them with training, because otherwise they're going to be left behind. And maybe by helping them with training, we can get them working on tasks that that are more rewarding and more interesting, and plays to our strengths, which are creativity and problem solving, rather than doing some task over and over again, which we tend not to do well after we do it so many times in a row. So, just keeping that in mind when we're developing these algorithms. And then the other thing, as Sean mentioned earlier, is that there is some concern with these algorithms being developed. We mine like hundreds of millions, billions of images off the internet, and some of that content is quite inappropriate, and that can be baked into our algorithms. And so we have to make sure that we keep in mind how we use these and what sort of biases might be in the data that can negative affect people that are using the algorithms that we build. And so that's a really important piece. We often just like to, let's try to solve this problem. It's so exciting. But we have to keep in mind, the people that it may affect by the decisions that we make. So that's also a really important component of it.
I'm going to stay down the curious theme because I think it's incredibly valuable, because curious also means creative to me in some worlds, and I am not that creative at all. And thank God to AI, I actually have some quality images that I've baked into my speeches. But I want to go down that path just because if you two are like me, very practical thinking, very technical, borderline like huge nerd, the way that you can get more creative is to use the tool to think like a bad actor and solve real problems. And I say that sincerely, in that half the reason in fraud, we actually do tabletop exercises to say, what would a bad actor do in this scenario? Well, they'd steal my ID, then they'd pretend they were me, and they would go, do various functions. Or on the transportation, they'd get the data, they'd map it out, and they'd find the various exit points that are most vulnerable. If you put on that bad actor hat and think a little bit creative in that respect, you can create a lot of good because you're trying to do good, if that makes sense. And I'll go right down into every time we lean into an AI tool, and I'll say ChatGPT is so happened to be my favorite. There's also a fraud GPT with the same subscription model. So if you can just leverage that mentality to be creative and curious in those realms, you can do a lot of good with it, especially when you put it in the hands of the youth.
I'm going to give kind of a bit more, maybe like a general comment here rather than discipline specific. And the first being that I kind of look at the AIs as like a bunch of like different friends at a bar. And so I have I got ChatGPT, I got Gemini, and I got Perplexity. And I don't know, Grok is usually on the other side of the bar right now, but we'll be nice to Grok. And so, I got these three different people I'm kind of talking to, and one of them is really great at writing research papers, and one of them is really great at writing code. And what I often do is I will kind of use them against each other a little bit, where I'll pull something from ChatGPT, I'll get it to do a deep research, send it over to Gemini, and I'll say, hey, Gemini, what do you think of that? And Gemini will say, oh, that's pretty good, but there's a couple things I got to change here. I'll bring it over to Perplexity. Didn't really add anything, so okay, bring it back over to ChatGPT, and then that will start to give me a bit more information. And through that, I find that like I'm almost doing research because I'm reading it all over. I'm saying, okay, yeah, that sounds kind of good, and then there's some aspects where I'm like, that's no good. And then by the end, I'm going to have to sift through it a bit more, but it usually gets something quite lovely because I'm like working with like a team of 3 different thinking individuals. And then the other thing I wanted to finish on, which I thought you had a really great point, is I'm a bit of a disruptor sometimes, especially when it comes to like software and hardware and stuff. And so I often like to try to break things. That's usually like the first thing I always do. And maybe that's like my childhood nature is like, all right, how can I poke this machine and how can I do things I'm not supposed to do with it? And so that is one thing I always encourage everyone to do because you're not going to blow up the world texting with ChatGPT. It's not gonna happen. But you can really start to play with it and start to understand what it's good at, what it's bad at, what it will do, what it won't do, what you can make it do if you trick it. And I kid you not, like sometimes I will have to change the wording to do things. They'll say, I can't do that for you. I'm like, all right, well then how about I word it this way? All of a sudden it can do it for me. And so it's that idea of just kind of breaking down those walls with it and realizing that, yeah, you can kind of hurt ChatGPT's feelings. It's not a person. You can kind of mess with it a bit more. Do not do that to regular people in your real lives. But we have this opportunity with this system that we can do that. And the more we experiment with it, the more us as individuals are going to understand it. Because if we just give it basic tasks every day and it gives us basic answers, to me, well, you're just going to stick with that. So I would suggest that you grab a couple of friends and you start messing with them.
Excellent. Well, we will leave it there. Thank you so much for a wonderful conversation, Jason, Chelsea, Chris, and Sean. Yes, let's give it up for the panel here.